Okay, guys. Now, I want to show you two things. Okay, this here. See the way it's not really even. See the way it goes up and down, but it can be. That can also be something like that. It's a bit irregular. Okay. Now that leads me to believe it's a cubic equation with something behind it. But the bottom line is the highest power is a cubic. Is everybody happy with that? Now, second one. See the way it starts off as 0, 0, and it keeps going up and down, up and down, up and down. Anybody tell me, is that a sine function or a cosine function? Because sine 0 is 0, while cos 0 is 1. If it was a cos function, it would start here. So we can see that this is a sine function, while this one here is a cos function. Everybody happy with that? Now, next thing. This won't be hard to gauge, but it tells me in the question that it's an exponential function. Now, it's a decreasing exponential function. So, if it was e to the x, it'd be going on its way up. If it's e to the minus x, it's on its way down. You can check this in your calculator. So, it's e to the minus something. I'm just going to say e to the minus x. It might not be minus x. It could be minus 2x, minus 3x. E to the negative power, anyway, okay? Now, finally, the last one. Standard quadratic with an x squared in it. Okay? Now, what happens when we differentiate? Well, when we differentiate sine, change the cos, so we can we can that one to that one there, yeah. When you differentiate x squared, you get x squared. That's a graph there, right? That's a U-shaped graph, quadratic. When you differentiate a exponential, it stays as an exponential. Let me show you why. If your first graph is y equals e to the minus x, yeah? Your second graph is going to be, when you differentiate that, the power never changes. What's the derivative of minus x? Minus 1. So your dy dx is minus 1 e to the minus x. It's the same graph, except you multiply it by minus 1. So that's why when you multiply a graph by minus 1, what does it do? Flips it. Turns upside down. Hence, that one goes to that one. And finally, when you do a quadratic, it turns into a linear. Okay? Now, let's start off with a linear equation. If you imagine that dy dx is equal to, I don't know, 3. 3x. Okay? Minus 2. That's a generic line formula, isn't it? Yeah. What happens if we differentiate again? It goes 3. And 3 is a straight line that goes straight across, isn't it? Y equals 3. So, your slant, when you differentiate a regular line, it then turns into a straight line, a flat line. So this one goes into here. Once again, the trigonometric just turns back into another trigonometric. It goes back from cos and it turns back into sine. The exponential once again decides to turn itself upside down because we're just going to end up multiplying by minus 1 again when we differentiate it. So we had it down here, and if I differentiate this, once again it's going to be e to the minus x. Differentiate the power, it's minus 1. Minus 1 by minus 1. It actually turns back to its original form. So e to the x will just keep changing into another form and then back to its original form. Not for all of them, but for this one, yes. Okay? And then finally, what's the last thing we needed? Is that them all done? And the quadratic will turn into a line. Okay? And then, is it alright if I just leave all you have to do is write all the letters down. So I'll get you guys to call them out for me. Okay? So, we're going to have to put them all in. So can somebody tell me, given what I already told you, can somebody tell me what is the quadratic function? Which one? K. First derivative? B. Second derivative? What? I. Cubic? F. First derivative? D. Second derivative?
Hi, Frank.
I. Okay. Now, what about the next one? Trigonometric? G. After that? A. After that? I. And then the last one is I4, is it? And then C. H. Thanks for that. For anyone, explain your choice of first derivative and second derivative. Well, I think the really easy one is to do the cubic. A cubic equation, when you differentiate it, turns into a quadratic equation. Quadratic equation, when you differentiate it, turns into a linear, and you're done. Okay. What I would actually do is I'd actually make up a cubic equation, something really easy, just like that, and then I'd say, look, the first derivative is a quadratic function, and the second derivative is the equation of a line. I'd actually just make up my own equation and spell it out for them. Okay. So that is question 5. Question 5 is reasonably easy. Have anyone's done it before? Yeah. Hopefully, right. Now, what we're doing next is we're going on to question 8. This one has I think it's raindrops dropping from, and there's a terminal velocity. Okay, so. Now, alright, let's. Okay, now, this one here is the speed at which a raindrop falls increases until a maximum speed, called this terminal velocity, is reached. The raindrop then continues to fall at this terminal velocity. So, for example, if you go skydiving, alright, when you skydive, you undergo, I think it's about 10 to 15 seconds of rapid acceleration, okay? So eventually you go so fast, so you might be going, I don't know, you'd be dropping so fast that the wind resistance on the way up balances you out, so you no longer have any acceleration. So when your acceleration stops, you're stuck at this speed until you basically pull the parachute. Okay, so that's the way it works. Okay, so this raindrop is based on this, that the raindrop will start falling, it drops from there, gravity accelerates it, and then eventually the wind particles catch it, and it stops at its maximum velocity. It keeps dropping, but it's no longer getting any faster. The rate at which it's dropping stays the same. Now, another thing you need to know, and this would have been covered, was when you're given a formula for S, and S is in terms of T, let's just call it a cubic, okay? The first derivative is known as what, guys? First derivative is the velocity, okay? And the second derivative is the acceleration. And that has to be learned off by heart, and you're to know that going into your exam, okay? Huh? First derivative is when you have a distance equation, first derivative is the velocity, second derivative is the acceleration. Okay, now, huh? It would only be that if it was ct as well. Yeah. It's a function with time, so that's only if it's t. Okay. Now, what we have here, guys, is how far has the raindrop fallen after 10 seconds? Well, look, it says that the S formula is related to 6 multiplied by time plus 0.3 times the time squared minus 0.01 times the time cubed. Just simply put 10 in for all of them. So 6 times 10 plus 0.3 times 10 squared minus 0.01 times 10 cubed. You're going to find that that turns into being 80 meters. Okay? Alright. Now, after how many seconds is the raindrop falling with 8.25? Remember, it says that this acceleration process is only applicable for the first 10 seconds. So 0 less than or equal to t less than or equal to 10. So when is it 8.25 meters per second? Remember, it's a U-shaped function, which means that it's going to, more than likely, it's going to hit 8.25 meters per second twice. Okay? Oh, sorry. Give me a second. Sorry. The distance equation is a cubic. Okay? So if S is equal to 6t plus 0.3t squared minus 0.01 t cubed, the velocity, which is ds dt, is going to be what's it going to be? It's going to be 6 plus 0.6t and then minus 0.03t squared. That's an n-shaped function, right? Yeah. So in an n-shaped function, what you're going to have is the maximum of this. The maximum of this is the maximum velocity it's going to reach. More than likely 8.25 is not the maximum. So there'll be two different times. This is now a velocity time graph. There will be two different times at which it reaches the 8.25 meters per second. There, Sean? Okay. So, yeah. What it says is that, what I'm saying is that we're going to evaluate this at the moment, right? And I reckon we're going to get two different things. So the velocity is 8.25. I'm going to solve this. Now what Keane said was correct. It's going to be a, I'm going to get two values for this, alright? And one of the values isn't going to work. Is everybody happy that this is a minus b equation? Or we can, it's just a quadratic equation. Bring out the decimal, you either do a minus b or you multiply it by a number so there's no decimals left. Okay, you solve it anyway, and what you're going to get is 2 times. The 2 times you're going to get are 5 and 15. Now, I can immediately discount 15 because 15 is not between 0 and 10. And as Keane said rightly, this then reaches a terminal velocity and the velocity then starts to flatline. Okay? So it would be located here, that's 15 seconds, but because 15 seconds occurs after 10 seconds, it's not a allowed answer. So the only answer to that question is t equals 5, once you solve this quadratic equation. Okay? Everybody cool? Now, next thing, the acceleration of the raindrop. Keyword acceleration. What happens when you see the word acceleration? Second derivative. And when you do the second derivative, it's 0.6 and then minus 0.06 t. Find the value of t for which the acceleration is 0.006. So that is 0.006. Okay, now this is an interesting one. So, 1 second. Yeah, we're good. So we're going to bring over the, we're going to say 0.06t on the right hand side, bring that over to the left, equals 0.6694, right? Bring it over and take it away. And then divide it by 0.06, and you get t equals 9.9 seconds. See this 8.25? This 8.25 is just before the maximum velocity, because it's going to hit the maximum velocity at 10 seconds. Okay. Now, the raindrop falls from a height of 620 meters. How long will it take the raindrop to fall to ground level? Okay. So we already know that t equals 10 is your maximum velocity. We know that the velocity equation is, where is the velocity equation? 6 plus 0.6 t. Alright, so 6 plus 0.6 t, and what was it? Minus 0.03 t squared, right? That's our velocity equation. Can somebody plug in 10 there? Just tell me what you get. 6.6 times 10 is another 6, isn't it? And then minus 0.03 times 10 squared. 6 plus 6 being 12, minus 3 being 9. Your maximum velocity is 9 meters per second. Okay? Now, how long will it take the raindrop to fall to level ground? Well, what I should do was, if it accelerates for roughly 10 seconds. So I should find the distance it covers in the first 10 seconds. Did I already find that? 80, perfect. Okay, so for the first 6 seconds it covers 80 meters. Then we have a remaining 620 minus 80, which is, we have 540 meters, and we're covering that at 9 meters per second, because time equals distance over speed, which equals 60, is it? And we have to add on the initial 10. 60 plus 10 equals 70 seconds. So guys, some people were questioning the terminal, where did the terminal velocity come from, and why isn't the thermal velocity affected by this equation here, k times t minus 10, yeah? Now the reason for that is ds formula is, what did we say was kt minus 10, s equals kt minus 10k. Now, what I say is velocity is the first derivative, right? Velocity is ds dt. ds dt for this equation Simon's in reference to is going to be k, just k. It's a constant. We had to find out what the constant was. See, that describes the distance, not the velocity. So all we're finding out is that your velocity is always the same. So that's why we use the end of the last part, the end of the acceleration phase, is the k value. So k is 9. Okay? Now, this one here, okay, it's actually reasonably easy, okay? A raindrop increases in size as it falls. The volume of the spherical raindrop increases at a rate of 6 cubic millimeters per second. What is that? Is it the VDR, the VDT, the RDT? Which one is it? Volume. Volume. Volume and rate. The words volume and rate in the same thing. The VDT. Okay. If it's given to you in the question, it's usually a DT. dt is 6. Okay. Now to get at the VDR, what you have to do is you have to get your volume of your sphere is, any sphere is 4/3 pi r cubed. To get the VDR, you need a equation with V and R in it. V in terms of R. Then you're allowed to differentiate to get the VDR. Differentiate that, you get 4 pi r squared. Then the question wants find the rate at which the raindrop is increasing when its radius is 5.1. Raindrop is increasing. What's the letters for that? The RDT. We want the RDT. Now what we can do with the VDT is change it into the VDR by dr dt using the chain rule, and that has to equal 6. What do we say the VDR is again? 4 pi r squared multiplied by dr dt, which is the whole point of the question, equals 6. Dr dt ends up to be 6 over 4 pi r squared for any value of r. However, in this question we're told it's a very specific value of r, which is 1.5. Put that into the calculator and you get 0.2122. Now please remember it's the rate at which its length is increasing, isn't it? So it increases by millimeters and it's measured using time, millimeters per second, or mms to the minus 1. Okay.